Hello dear children, once again welcome to maths class. Today we are discussing the second exercise of arithmetic sequence, which is the first chapter of class 10 mathematics. And this is the second question of third exercise. Look at these pictures. If the pattern is continued, do the numbers of colored squares form an arithmetic sequence? Give reasons. Colored squares means these squares. Okay, these are the colored square in your textbook. Okay, these are the colored squares. And if the pattern is continuing like this, is it form an arithmetic sequence or not? That's our question. See, how many colored squares are there in the, how many colored small squares are there in the first picture? See, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 squares. And for the second one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares. And for this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Then, what about these numbers? 8, 12, 16. So, what is the difference between each terms of the sequence? First plus 4 gives the second. Second plus 4 gives the third. And the next number should be 16 plus 4, that is 20. So, this is our sequence. Is this an arithmetic sequence? If it is an arithmetic sequence, there exists a common difference. Can you find a common difference here? Yes. What is that common difference? Yes. The second term minus first term. Okay. Second term minus first term. Second term minus first term gives 12 minus 8, that is equal to 4. And third term, let us write third term as x3 and second term as x2. Then x3 minus x2 is equal to 16 minus 12, that is equal to 4. That means there exists a common difference. Since a common difference is here, we can say that this one forms an arithmetic sequence. Okay. Then third question and fourth question. Third question and fourth questions are very simple questions. Okay, so do that two problems as homework. Okay, now we are going to do the fifth problem. Now we are going to do the fifth problem. In this picture, the perpendiculars to the bottom line are equally spaced. Prove that continuing like this, the length of the perpendiculars form an arithmetic sequence. So this is our question. Here you can see two lines. One is a horizontal line and one is slanted line. Right? And these are the perpendicular drawn to the horizontal line from the slanted lines. These are perpendicular lines. These are perpendicular lines drawn from the slanted line to the horizontal line. Okay, and these are equally spaced. These are equally spaced. That means the distance, this distance, this distance, this distance, all these distances are equal. That means AB is equal to BC is equal to CD is equal to DE is equal to etc. Okay, all such distances are equal or the perpendiculars are placed equally. And we need to prove that length of the perpendiculars form an arithmetic sequence. Length of the perpendicular. Which is the length of the perpendicular? Yes, PA is the length of the first perpendicular. BQ is the length of the second perpendicular. And RC is the length of third perpendicular and so on. Okay. And we need to prove that this PA, BQ, CR, DS, T, etc. That length form an arithmetic sequence. Okay, how do we prove this? We know this picture from 9th standard. Do you remember? Okay, let us listen. First, I am going to give this length PA as X. Okay, I am going to give this PA as X. Okay, this length is X. PA's length is X. Now, I am going to draw like this. Okay, and I want to prove that all these distances are equal. Okay, I want to prove that all these distances, see, this and this one are equal, right? So, we need to prove that these distances are equal. Okay, ഈ ഡിസ്റ്റൻസസ് എല്ലാം ഈക്വൽ ആണെങ്കിൽ എല്ലാത്തിനും കൂടുന്നത് ഇത് മാത്രമായിരിക്കില്ല എവിടെ കൂടി പോകുന്നത്. ഇവിടെ നോക്കിക്കേ, ഇവിടെ അതാണ് കൂടുന്നത്, അഗെയിൻ ഇവിടെ അതാണ് കൂടുന്നത്, ഒരേ ഡിസ്റ്റൻസ് ആണ് കൂടി പോകുന്നതെന്ന് നമുക്ക് പ്രൂവ് ചെയ്യാം. ഓക്കെ, സോ ഹൗ ഡു വി സ്റ്റാർട്ട് ദിസ്? യെസ്, ഫസ്റ്റ് ഐ എം ഗോയിങ് ടു നെയിം ദിസ് പോയിന്റ്സ് M, N, O, P, not O, M and O, that's enough. Okay, so first consider this triangle PMQ. Okay, first consider this triangle PMQ. Triangle PMQ. And next triangle QNR. Okay, so first consider two triangles PMQ and QNR. Okay, we know that these two lines are parallel. Then what about this angle? This angle is equal to 90 degree, right? What about this angle? That angle is also equal to 90 degree. And what about this angle? That is also equal to 90 degree. Okay, all these angles are 90 degree. Okay, so if we consider the triangle PMQ and QNR, we can see that these two angles are equal, right? These two angles are equal. That is, angle M and angle N are equal. And what about this length? This length, we know that all these lengths are equal. Therefore, these lengths are also equal. So, we can say that PM and QN are equal. Okay, PM is equal to QN. Okay, PM and QN are equal. So, we get these two angles are equal and these two sides are equal. Then, what about these two angles? Are they equal? Yes, they are equal. Right? They are falling on the same slanted line. So, all these angles are equal. Right? All these angles are equal. That is, we have angle P is equal to angle Q. So, for this triangle PMQ and for triangle QNR, we have one side of each triangle and two angles on it are equal. Right? One side and two angles on it of triangle PMQ are equal to one side and two angles of the triangle QNR. Therefore, we can say that triangle PMQ and triangle QNR are equal triangles. Okay, triangle PMQ and triangle QNR are equal. Okay, so we can say that triangle PMQ and triangle QNR equal triangles. Okay, what is special about equal triangles? For an equal triangle, the angles opposite to equal sides are equal. Similarly, the sides opposite to equal angles are also equal. Okay, so we have these two angles are equal. Then the side opposite to this angle P is this MQ. Right? and the side opposite to this angle Q is Rn. Okay, so we have this QM and this Rn are equal. So, since triangle PMQ and QNR are equal, we can say that the sides QM and Rn are equal because they are the sides opposite to equal angles. Okay, sides opposite to equal angles. Similarly, if we consider the triangle QNR and RDROS, we have these two triangles are equal. Then we get this length Rn and this length SD are also equal. Okay, similarly if we consider these two triangles, we will get these two sides are equal. Okay, that means we get QM is equal to Rn is equal to SO is equal to like that. Okay, so we have PM is equal to, not PM, QM is equal to Rn is equal to SO is equal to etc. All such distances are equal. And if I give the length QM as D, this length QM as D, and then this one is equal to D, this one is equal to D, this one is also equal to D. Okay, then if we consider the length of the perpendicular, the length of the first perpendicular PA is X. Okay, then what about the second perpendicular? What about the second perpendicular BQ? Yes, BQ is equal to, yes, this length is X. Okay, this length is X, and what about this length? That is equal to D. So, total length is equal to X plus D. Okay, now say what about this length? This is equal to D and this one is equal to X. Then what about this length? That is equal to D. That is X plus D plus D. So, the length of the perpendicular RC is equal to X plus D plus D. X plus D plus D means X plus 2D. Okay, then what about the next length SD? SD is equal to, yes, X plus D plus D plus D. That is equal to X plus 3D. So, is this form an arithmetic sequence? See, first one is X, second one is X plus D. So, starting with a fixed number and adding a fixed number continuously, we get the length of these perpendiculars. Right? Therefore, this one form an arithmetic sequence. What form an arithmetic sequence? The length of the perpendiculars form an arithmetic sequence. Okay, children? So, what is the reason? Because here exists a common difference. Therefore, this one is an arithmetic sequence. The length of the perpendiculars form an arithmetic sequence. Okay. Now we are going to do the last problem or the sixth problem of this exercise. Question is, the algebraic expression of a sequence is xn is equal to n cube minus 6n square plus 13n minus 7. Is it an arithmetic sequence? This is our question. See, this one is the algebra of a sequence. Okay, algebra of a sequence. In this sequence, if n is equal to 1, we get the first term. If n is equal to 2, we get the second term. N is equal to 3, we get the third term, and n is equal to 4, we get the fourth term. So, first I am going to find out the terms of this sequence. By giving different values to the sequence, I am going to find out the terms of this sequence. Then only we can say that whether this one is an arithmetic sequence or not. Okay, first I am going to find out the first term. Okay, that is x1. First term is x1. x1 is equal to, yes, in the place of n, I'm just substituting the value 1. Okay, that is 1 cube minus 6 into 1 square plus 13 into 1 minus 7. What is that? That is equal to 1 minus 6 plus 13 minus 7. That is equal to, yes, 1 minus 6 is equal to minus 5. Minus 5 plus 13 is equal to 8. 8 minus 7 is equal to 1. Okay, so the first term is equal to 1. Then what about the second term? Second term is equal to, yes, 2 cube minus 2 into 2 square plus 13 into 2 minus 7. That is equal to 8 minus 2 square 4. 6 into 4 is equal to 24 plus 26 minus 7. That is equal to 3. Okay, then next is x3, that is 3 cube minus 6 into 3 square plus 13 into 3 minus 7, and that is equal to 5. Okay, by seeing the first, second, third term, we can say that this one is an arithmetic sequence, right? Because 1 plus 2 is equal to 3, 3 plus 2 is equal to 5. But I am going to find out one more term. Okay, that is the fourth term, x4. That is equal to 4 cube minus 6 into 4 square plus 13 into 4 minus 7. And that value is 13. Okay, that value is 13. First term is 1, second term is 3, third term is 5, but the fourth term is 13. So, is it an arithmetic sequence? In an arithmetic sequence, the difference between two consecutive terms will be equal. Okay, we have 3 minus 1. Okay, that is x2 minus x1 is equal to 3 minus 1 is equal to 2. And x3 minus x2 is equal to 5 minus 3 is equal to 2. That are correct, right? But what about x4 minus x3? x4 minus x3 is equal to 13 minus 5. That is equal to 8. That means there does not exist a common difference. Therefore, we can say that this one is not an arithmetic sequence. Or this is not the general form of an arithmetic sequence. This is an arithmetic sequence in the general form. Is it clear? Okay, children. Thank you. This much only for today. And you have to complete your homework. Okay. Thank you.